Okay, YouTube, in this, my second video on solving linear equations, we're going to look at our last example in which we solved a linear equation, which is this one right here, but use a graphing utility to actually help us do it. So I want to illustrate how we can do this using both graphs and tables on, say, a TI-83. So you'll notice that I say here, entering both sides of this equation from the previous example into a calculator for y1 and y2 respectively, then we could actually use the graph function or the table function to do this, use graph or table. So essentially what we're going to do is we're going to say, well, this right here, what if it were its own equation? Y were to be equal to something in terms of x here, and we'll call that y1, and we'll call this y2. And then we're saying that where is y1 equal to y2 at? You know, what x and y pair do they have in common? Because that would be the x and y pair that would cause this statement to be true, okay? So what we're going to do here is, and I have my calculator, as a matter of fact, if I turn this on and go to y equals, you're going to notice that I've kind of worked ahead a little bit here, but I took this left expression and I've typed it in for our y1 equation, 4 times the quantity 2x plus 1. And then also likewise with the right expression, I've typed that in. But if I hit graph right now, you'll see that we have these two linear equations and it doesn't look like they run into each other at all. The idea here is, and I've given a suggestion, is that we're going to have to change our viewing window. And so the viewing window that I'm suggesting right now would be using 0, 10, 1 for our x-axis and 0, 100, 10 for our y-axis. And recall this means that we're going to have an x-axis that goes from 0 to 10 and going by ones. And we're going to have a y-axis that goes from 0 to 100 going by 10. So I'll go to my window option here. We'll say, well, I'll start at 0 on my x, go to 10, we'll go by ones. And I'll start at 0 on my y, we'll go up to 100, and we'll actually go by units of 10. So when I regraph this now, we can say 0 to 10 on my x and 0 to 100 on my y. We can see these linear equations much more easily now. So the question is, are there any x's and y's that they have in common? And I notice here that they have this one right here, whatever this is. And if I had to guess, I could say, well, it looks like 1, 2, 3, 4, 5. X looks like 5, and if I were to count up and over, we can say the y value looks like it's maybe like 1, 2, 3, 4, like in the 40 range, okay? So the two ways we can find this solution on a calculator, the first one is actually this. We can actually just go to our table. And you'll notice that my table right now is starting at -3, but we said when x is equal to 5, we think we have a common ordered pair on both graphs. So if I scroll down here, we can go out to where x equals 5, and we can see that both of these equations, in other words, both sides of this equation would be equal to 44 if we were to plug in 5 for x, okay? And I do want to look at this. If you tuned into my last video here, you'll notice that when we did solve this equation, we started by simplifying both sides and combining like terms, and then we, got all the x's on one side and then got everything away from the x. What I want us to see is that we actually got an x value of 5 when we solved this equation. And then what I did was I went back and I plugged it in to the original expression for all the x's, and I got 44 is equal to 44. In other words, both sides are equal to 44 when our x is equal to 5. So the way that manifests itself in the table is we can see that they are both in common when they have this common x value here. So we would say that the common solution point would be 5, 44. So they intersect at 5, 44. And that's interesting that I say they intersect at 5, 44, because if I now go back to the graph, what I want everybody to do is use this menu behind this button that we see is called trace. Now if I hit trace and just hit left and right, I want you to see what this does. It kind of just traces along the curve and it says you're approximately at this solution pair for that graph. We're approximately at like 2.12, 21.02 for this y1 graph. And if I hit up, you notice it skips up to the other curve. So up and down skips you back and forth. What we want to do is go behind trace and go to this calc menu. And we're going to look for this fifth option that says intersect. I'm going to hit 5. And what it's going to do is it's going to ask you, what's your first curve? Because you might have 5 curves up on the screen. We say, well, you're trying to find which ones intersect. Well, I'll say, this is my first curve. You'll notice that it pops immediately over to my second curve. And then I'll hit enter again. It says, okay, well, now you've told me the two curves. It says, guess where they intersect. Tell me where you think that they have a common solution pair, where they're equal to one another. And if I go over here and I just hit enter next to this, it says, well, then they're common at 5, 44. So the easy way to solve this equation, we'd say, well, then the x value that's in the solution set for this is going to be 5, okay? And it's because these two graphs have a value of 44 if you plug 5 into both. So that's how we can use a graphing utility to help us solve these. Going forward, when we solve the rest of these by hand, we'll also check them on a graphing utility. Cheers.